So the formulas that we have for the pipe slope, for the friction slope, I've shown it here as if you would actually write it in Excel so you can see what parentheses open and closed parentheses and what locks. Now this is truly the formula that is inside that cell, so if you need to take a look at it, take a screenshot of it right now during the video, then you can do that and you'll plug that formula in. Now, here's one of my pet peeves. Apparently I unhighlighted, so I'm going to fill in that area so it all looks nice. Okay, now, the next part of the project, it says, so we recorded the size and we assumed it was 18. Now, the 18 comes from just the first guess. Now, this is how I would base it on. The notes say that using the hydraulic calculator, an 18-inch pipe is acceptable because the friction slope is 0.03 and it's flatter than the actual preliminary slope. What if I used a pipe size that was 15? And this is the nice thing, again, about Excel. What if I changed my mind and I used 15 and span and rise of 15? Then the friction slope would be 0.00075, and it's still smaller, so 15 would have worked. But what if I used a 30 and 30? Then if I'm a 30-inch pipe, the friction slope is still smaller. So you're looking at that point, it's not only the friction slope that I would base my first guess on. In all honesty, I would base my first guess on is how much flow will an 18-inch pipe carry at the friction slope or at the flowing full. So over here, if you look at this capacity, velocity and capacity pipes flowing full, I have an 18-inch and an 18-inch. Manning's in 0.012 with a, we assumed that friction slope, if we use the hydraulic grade line, is 0.0018. Go back over here. 0.0018. It'll have a velocity of 2.7, but take a look at the formula. It's velocity times pipe area. Remember what I said about the beginning? The equations that we use, here's an example of it, Q equals VA right here, is basically the continuity equation. So we'll be using that a lot in these formulas. So what you're looking at when you're designing pipes that are flowing full is you need to look at how much capacity the pipe will actually have. When somebody says capacity, they're talking about CFS in the pipe. So somebody might say, well, what's the capacity of the pipe? How much flow goes through the pipe? Now, the next part is what we're actually looking at is it has to have a minimum physical slope though. The pipe has to be at a certain slope that it carries a velocity of 2.5 feet per second. So remember, Q equals V times A, velocity times area, but we said the velocity of Manning's equation is that 1.49 over N blah blah blah. Well, we have it here. Velocity times N, but instead of using Q, notice that it has a V, whereas up here it has a Q and an A. Well, Q is divided by A. So if I had velocity, velocity equals Q divided by A. Whoops. Q divided by A. All right? So in this formula for physical slope, we want to find, we're using basically the same formula, but instead of Q and A, we're just going to go ahead and say velocity because we know the minimum velocity we want is 2.5. So in the formula here, if we look at it, and I'll write it over here. This is the long one. Ignore that. That was the complicated one. Does the same, but we're gonna use this formula here. It's going to be 2.5 times the Manning's N, because 2.5 is our cleansing velocity. If we decided to change that to 3.5, and this is where I said that I like to reference cells, if we ever change that to 3, I would physically have to change that cell because I'm not referencing the 2.5. So in this one, I did go against what I normally do, but I didn't feel like making an extra cell location. So I'm going to copy this one, and I'm just going to bring it up here, because right now, this cell is that long formula. So I already rewrote it down here. So when I copy this one, and I paste it up here, it's the same. So I know that the formula, the long formula, still works the same. All right, now, the next part of it, go back to our assignment. It says, although it is not necessary to record the hydraulic slope at this step, it will be used later when moving up the system and calculating the hydraulic gradient. It may save time to record this while the hydraulic calculator is set for the pipe, for the flow and the pipe size. That's why I did all of this. If you look at the final solution on the last page, you don't have all this stuff spaced in there. I did that specifically so I could start explaining and doing the math, and so I don't have to write it down. The computer carries it for me. The next part, it says, step 11, determine the pipe flow line's physical slope and fall from P1 to 2. For this example, we use 4.5 foot of clearance between the inlet at the edge of pavement elevation and the flow line of the 18-inch pipe. The minimum clearance for the 18-inch pipe is in a precast type P-5 structure is 4.2. Where did that magical number come from? See that table? I went ahead and put it down here. It's not in Urals. I accidentally erased it. Oops. So here is the table that they're referencing. It is recommended distance from inlet to pipe flow line. So if I come down here, it says curb 1 through 9. So it's going to fall into this section here. So the 18-inch pipe has a recommended 4.2. Let's draw a picture of what that really means. So if this right here is my, if this is my inlet here and it's at 10.90, it's saying that it has a minimum from here to here has a minimum of 4.2 feet. That is the base, that's as shallow as it will go. But if you read the instructions, it says that they're going to use a 4.5 for the minimum clearance. So if you look at the instructions, it says we're going to use 4.5 as the clearance. Excuse me. So we're going to take the 10.9 minus the 4. So we're using 4.5. Oops. We're using 4.5, and we're going to come up with an elevation of 6.4 down here. Okay? So that's going to be our first invert of the pipe, and we're going to build it going downstream. Everything's being calculated downstream. When we get to the hydraulic grade line, that's not going to be true. So right now we're building downstream. Now the invert to the next pipe has to be lower, right? Now here's one more thing that I want to show you. And I'll post these tables online. They won't be in your Excel sheet, but I will get them online. It says minimum physical slope with a Manning's N of 0.012. The diameter, 18 inches. The slope is 0.15%. So that's 0.0015. Look what we calculated. Based on 2 feet per second, 0.0015. So you can look at a table or you can type in a formula. I'm big on formulas, and I'd rather do a formula than a graph or a table. At least I know where all the numbers come from. All right, now, oops, wrong one. So it says, for this example, we'll assume there are no constraints such as utilities that would prevent the pipe from being set at the minimum physical slope of 0.15. What that means is if there were utilities, if I drew my picture, if there was a water main line that's running into the system, or there's another line that's running parallel, we don't want to conflict with the water main. Let's say there's a water main line that goes across it. we have to be under it or above it. So it's assuming, what this is doing is saying we're assuming that there's no confliction or no conflict, that we can't build it at the minimum physical slope. All right, so what we have to do is we have to figure out the minimum pipe fall. So if we know the minimum physical slope is 15 or 0.15%, we're going to take 0.51%, we're going to change that to foot per foot, so it's 0.0015, and I leave mine mostly in percent, and multiply it by the length. So if I look at this over here, where it says fall, here is my formula. The minimum fall in the length of pipe times the minimum physical slope. So if I look at that formula, all it's saying is I'm taking the length of pipe. Let me get on to the right slope, or the right one. And up here, this is where I give you the hint or the tip of, this is the assumed clearance between the ELP and the flow line. They want 4.5, so the upper end of the invert is 6.4. So if you look at that, I even literally wrote a formula for that. So in case I ever changed my idea of what the top of the structure was going to be, so that minus the 4.5 gives me the 6.4. The minimum slope here basically says, okay, I'm going to take the physical slope, the minimum at the 2.5 velocity, and I'm going to multiply it by the length. So let me scooch this over. Multiplied by the total length. So now that cell is linked. Those two cells are linked. So if I ever change the length or the size of my pipe, everything gets updated. Again, take a look. So right now, it's only a 2-foot drop. Now, 2 feet, 0.2 feet isn't very much, but that's normal here in Florida. In other states, maybe not so much. What if I changed it to 500 feet? Will this increase or decrease? So that drop, if I change that to 500 here, now it's dropping 0.7 feet. Okay. So I'm going to undo that. So this is the drop in the pipe from structure to structure. So if you're looking at this, if I projected a line from, let me use a different color, from this point right here to this point right here, it's bad drawing, I know, but that's only 0.2 feet, that difference between this to this, okay? So that's what the fall in the pipe, they call it fall. Now, going back to the instructions. So we have that fall, and we look at that, and it actually is 0.18%. The physical slope. If I take the 0.2 divided by the 110, okay? The 110 times 0.15 gives me 0.17. They want you to round it to the nearest foot. That's why it's 0.2. Now, if you look at my formula, this is here's my formula, and you're saying to yourself, why is it 0.2? Up here in this number area, I can extend that to as many decimal places as I want, and it's actually 0.1649 blah, blah, blah. But they want it to be rounded to 2, or to the nearest 10. Now here's the thing, in Excel, it holds every single value that you have. If you want it to truncate, you can use TRUNC parentheses and shorten it, or when I go to put up the fall up here, I can tell it to round up to one place. And that's where you see round up equals round up that number, comma, 1. Okay? That allows you to, instead of having all the decimal places, it holds it to that 10th value for you. Okay, at least that's what I've seen. I don't use round up. I'm not a big fan of rounding until the very end. Okay, so there's our fall is 0.2. Now, going back to the instructions, the next thing it says, okay, if I do use literally 0.2, what's the physical slope? So 0.2 divided by 110 feet. So if you look at this, over here, I've got 3 slopes on this side. I've got slope in percent, hydraulic grade, physical, and minimal physical slope. Now, the hydraulic grade is from the SF. That's your friction slope. So if you highlight that, I've referenced this cell. Okay. Now, I could have put all of this data, boop, right there. But I like to be able to see where all my stuff has come from, and I can reference to it when it's just a solid number. The physical slope, if I look at this one, it's referencing this cell here. So the physical slope is just that 0.2 divided by the 110. So if I look at that, that's the 0.2 fall divided by the 110 feet in length. So the physical slope, the middle one, is referenced here. And the last one, the minimum slope based on a cleansing velocity of 2.5 is from here. All right? Now, we're going to pause here, and then we'll go on to the next step.